We tend to think of simulation theory as a product of Silicon Valley, something that emerged from the same cultural moment that gave us smartphones and billionaires. And in its modern form, that's partly true. But the core intuition of that idea, the thought of what we call reality, might be kind of constructed. And there could be something more fundamental behind it. And that intuition is old. Around 380 BC, Plato wrote one of the most famous thought experiments in human history. And it was in a dialogue called The Republic. Imagine, he said, a group of people who have been chained inside a cave since birth. They're facing a wall. Behind them, there's a fire. And between them and the fire, people walk carrying objects. The prisoners see only shadows those objects cast on the wall in front of them. For those prisoners, the shadows are reality. They've never seen the objects, only the projections. They've built an entire language, an entire understanding of the world around shadows. And if you freed one of them, dragged them out into the sunlight, the real world would seem wrong, painful, and incomprehensible. Plato's point was about the difference between appearance and reality, between what the senses report and what actually is. He believed that most people live their lives watching shadows. That genuine reality, what he called the world of forms, was something we can only glimpse through reason. The structure of his argument maps almost perfectly onto simulation theory. There's an underlying reality. We experience the projection, and the projection is internally consistent. And escaping it, even glimpsing it, would feel alien and disorienting. He was writing this 2,500 years ago. If we jump forward to 1641, René Descartes is sitting alone in a room. History suggests he did much of his thinking in bed, which, frankly, relatable, honestly. And he made the decision to do something radical. He decided to doubt everything. And not as a philosophical game of some sort, but as a method. He wanted to find something that was indubitably, absolutely, certainly true. And to do that, he had to systematically destroy every belief that he held, just so he could see what would survive. He understood that his senses were unreliable, and that they were constantly deceptive. Mirages, optical illusions, and his dreams. Math, maybe, but what if he asks there's an evil demon, a supremely powerful deceptive being, who is dedicated entirely to making him believe false things? What if every time Descartes thinks he's adding 2 and 2 and getting 4, that a demon is feeding him that experience, and that it's incorrect? That's the evil demon hypothesis. It's called Descartes' demon. And it's the 17th century version of the simulation argument. What if there's some external, powerful entities whose entire function is to feed you a consistent but false reality? Descartes eventually clawed his way out of that thought with varying degrees of success, depending on who you ask. His argument was that the very act of doubting proves that there is a doubter. Cogito ergo sum. I think, therefore I am. But notice what he can't prove. He can't prove that anything outside of his own mind is real. And he just decides eventually that no good God would allow such a radical deception, which is a move that most modern philosophers find less than convincing. If we shift over to ancient China, there was a philosopher named Zhuangzi, and he was a writer in the 4th century BC. He recorded a dream. In that dream, he was a butterfly, fully, completely a butterfly, with no sense of him still being Zhuangzi at all. And then he woke up, and now he's Zhuangzi with no sense of being a butterfly. But the question that he left us with, is he a man who dreamed of being a butterfly, or is he a butterfly currently dreaming of being a man? It's a different flavor of the same problem. It's not literally, is there a demon deceiving me? But is there a fact of the matter about which experience is the real one? Maybe the question itself is wrong. Maybe the boundaries between self and world, dream and waking, are more porous than we can assume. What all three of those thinkers share, separated by centuries and continents, is a suspicion about the reliability of experienced reality. A sense that the world as it presents itself to us might not be the world as it actually is. They didn't have the vocabulary that we have now. They didn't have computers or quantum mechanics or information theory. What they did have was intuition, that unease, that sense that something about consciousness and reality doesn't quite add up. And it took until 2003 for someone to put that intuition into the language of probability theory. Nick Bostrom is a Swedish philosopher at Oxford. And in 2003, he published a paper called "Are You Living in a Computer Simulation?" And it became one of the most discussed philosophical papers of the 21st century. The argument's elegant. It doesn't rely on mysticism or intuition. It relies entirely on logic and probability. And once you understand it, it's kind of hard to shake. And it goes something like this. So if you start with a premise that most scientists and technologists accept, right? Consciousness is, at some level, a physical process. It's what the brain does. And if it's a physical process, then in principle, it could be replicated by any sufficiently powerful physical system, including a computer. Now, assume that civilizations, over time, tend to advance technologically. That's the historical record of our own species, and there is no obvious reason to think that it stops. A civilization that keeps advancing will, at some point, have the computational power to run simulations of minds, and detailed ones. Simulations where the simulated beings have experience, memories, and a sense of self. Simulations that are from the inside, indistinguishable from whatever you would call the real thing. If this is possible, and Bostrom argues that the physics does not prohibit it, then there's a critical observation to be made. A single civilization with that capability, running simulations for historical research or entertainment, philosophical inquiry, whatever reason, could run millions or billions of simulated minds. And that means that if such simulations are possible and are being run, simulated minds would vastly outnumber non-simulated ones. The ratio would be overwhelming. And that does raise the question, which type of mind are you? Bostrom states that there are three possibilities, and at least one of them must be true. So if you open door one, civilizations almost always go extinct before reaching the technological capability to run simulations. Something, whether an asteroid, a pandemic, nuclear war, some kind of catastrophe we may not even have imagined yet, reliably wipes out civilization before they get there. And if that's true, we're probably approaching that filter ourselves. Not the most comfortable thought, but as likely as anything else. If we look at door two, civilizations that reach capability choose not to run simulations, essentially universally. So for ethical reasons, or maybe the interest in running them disappears, or maybe because something about achieving that level of technological power can change a civilization's priorities completely. Whatever the reason, advanced civilizations don't run simulations. They could, but they don't. Door number three. We're almost certainly simulated. If advanced civilizations exist, and they do run simulations, then the overwhelming majority of minds in the universe are simulated. And since we have no particular reason to think that we are special, that we are among the vanishingly rare, real ones, the probability that we're simulated is extremely high. At least one of those is true, and we don't know which one. The argument's power comes from its structure. It doesn't say reality feels fake, therefore simulation. It says, given reasonable assumptions about the future of technology and given basic probability, the existence of vast numbers of simulated minds is either impossible, forbidden, or overwhelmingly likely. Pick your door. But we should definitely take a moment to look at what the argument does not depend on. It doesn't depend on any specific technology existing today. It doesn't depend on knowing who runs the simulation or why. And it doesn't depend on the simulation being perfect, only on it being detailed enough that the beings inside can't tell the difference. Bostrom himself has said he suspects door 1 or 2, and that psychologically seems safer. But he can't rule out door 3, and neither can we. What would it mean if it were true? Does the universe offer itself any hints? Philosophy is one thing, but physics is supposed to be the discipline that deals with what it actually is, objectively, something measurably real. So, what does physics say? The answer is strange, honestly. And some physicists even think it's strange in a way that looks kind of like a simulation. Let me be clear before we go any further in this project. Nothing in physics proves that we're in a simulation. There's some suggestive observations, but no, evidence. That's an important distinction, right? Because they're worth taking seriously, but they're deeply weird, and that weirdness deserves some attention. At the smallest scale we can measure, the Planck scale, around 10 to the minus 35 meters. Something unusual happens. Space appears to be quantized. There seems to be a minimum unit below which you can't meaningfully divide it further, right? If you look at it that way, you can think reality has pixels. And we could have a perfectly natural physical explanation that has nothing to do with simulation, and probably it does, right? But it's interesting that if you were to design a simulation, you would almost certainly do something like this. You wouldn't simulate continuous infinite detail, you would set a resolution limit, like a maximum zoom, and beyond that there would be nothing to render. Our universe appears to have exactly that. The observer effect is a note in quantum mechanics that's been around for a century or so at this point, and physicists have been arguing about it the entire time. Quantum particles, before they're measured, don't have definite properties. They exist in superpositions, in multiple states simultaneously, right? When you measure them, they collapse into a definite state. But before measurement, it's called a probability cloud. After you measure them, they have a specific concrete reality. The act of observation, the interaction, appears to force reality to become determinate. If you want to take a cynical approach to this, the universe only renders things when they're being observed. Like a video game that only loads the part of the map that you're currently in, right? Because why waste processing power rendering the far side of a galaxy in detail if nobody's looking at it? Again, quantum physicists have many interpretations of this that have nothing to do with simulation theory. The many worlds interpretation, right? The Copenhagen interpretation, the pilot wave theory. None of those require a programmer, but the resemblance to computational efficiency is hard to ignore entirely, right? Max Tegmark, a cosmologist at MIT, has spent years developing what he calls the mathematical universe hypothesis, right? His claim is that the universe is not described by mathematics. The universe is mathematics. Not a physical thing that happens to follow mathematical laws, but an abstract mathematical structure. That's all it is, and that's all it needs to be. If he's right, then the line between a real universe and a simulated universe kind of blurs. If reality is fundamentally mathematical, and a simulation is a mathematical structure running on some kind of physical substrate, then what exactly is the difference? Is there a difference? Tegmark thinks that his idea is deeply underappreciated, and most physicists think he's gone too far. And the debate is just going to continue. Then we run into the fine-tuning problem. The fundamental constants of the universe, the strength of gravity, the mass of the electron, the cosmological constant, all of those things are set values that allow complex matter to exist. If you nudge any of them, you get a universe with no stars, no chemistry, and no life. And those values, by any reasonable measure, are improbably precise. Now, there are non-simulation explanations for this, of course. The multiverse hypothesis says that there are countless universes with every possible set of constants, and we're in this one because it's the only kind where someone could exist to observe it. And that's the anthropic principle. But if you want to read it simulation adjacent, I guess. If you were designing a universe to produce interesting, complex outcomes, conscious beings, history, drama, you would tune the constants exactly that way. The precision would look a little less cosmic luck and a little more like deliberate engineering. It would look like it had selection bias, depending on which door you're standing at. My summary, as honest as I can put it, would be that physics doesn't give us evidence of simulation. But it does give us a universe that is far stranger than our intuitions may suggest. And that strangeness does leave room for questions that we don't know the answers to. So far, we've given simulation theory a generous hearing, right? That's appropriate considering the video's about simulation theory. And the arguments deserve to be understood at their strongest before they're challenged. But there are a lot of serious thinkers who push back hard. And their objections can't just be discarded as instinctive discomfort, right? Some of them are substantive. Bostrom's argument assumes that simulating conscious minds is computationally feasible, that you could, with enough processing power, run a mind. But that assumption is doing an awful lot of heavy lifting. We don't know what consciousness is. We don't know if it's the kind of thing that can be reproduced by computation. And there are serious philosophers. David Chalmers has spent his entire career on this. He argues that the hard problem of consciousness is genuinely hard and possibly intractable. The gap between physical processes and subjective experience, right? Why it is that you are like you might not be bridgeable by adding just more processors. And even if we set consciousness aside, simulating the physics of an entire universe to the level of detail that produces chemistry, biology, history, most importantly, experience, might require a computer larger than the universe itself. The simulation might be physically impossible, not just practically difficult. And if that's the case, then door one to Bostrom's trilemma might not actually be reasonable. Sabine Hossenfelder is a physicist and a science communicator who is not shy about her views. She has said plainly that simulation theory is not science, it's philosophy, and in her view, not a particularly good one. Her core objection is that if a theory makes no predictions that could, even in principle, distinguish it from an alternative, it is not a scientific theory, it is a belief. If we're in a simulation, what would be different? What could we measure? What could we observe that we couldn't observe in a non-simulated universe? If the answer is nothing, then the theory explains nothing. It adds nothing. It's not doing any form of scientific lifting. And that's a fair challenge. Some researchers have tried to find potential signatures, statistical anomalies in cosmic ray distributions, for example, that might indicate that we're running on a discrete grid, but so far they haven't found anything. And there's a bigger problem. Any anomaly a simulation might produce could also have a natural physical explanation. Hossenfelder's view is that taking simulation theory seriously as physics is categorically wrong. You're applying the vocabulary of science to something that, by definition, science can't reach. If we're in a simulation run by some civilization, call it the base reality or whatever, then what is their reality like? And are they simulated by something above them? The logic that produces Bostrom's trilemma applies at every level. If we grant that simulation is possible and likely, then we have to grant it for the simulators too. And their simulators. All the way up. This either ends at some level of true physical reality, which is fine, but then we're left asking why we couldn't be at that level, or it regresses infinitely, which creates its own philosophical problems about what real even means. The simulation hypothesis, if it's true, doesn't actually explain reality, it just changes the definition. There's also a more subtle statistical objection. Bostrom's argument assumes that we should reason as if we are a random sample from the space of all possible minds, that with no special knowledge of our situation, we should be able to apply probability proportionally. This kind of reasoning, called anthropic reasoning, is notoriously slippery to deal with. It's the same framework that produces paradoxes like the doomsday argument, which claims to prove that humanity will almost certainly go extinct soon, based purely on your position in the sequence of all humans who will ever live. If anthropic reasoning produces conclusions we find absurd in other domains, then we should probably be suspicious of it here too. Maybe the probabilistic argument of simulation is built on a foundation that we don't yet understand well enough to trust. None of these objections definitively closes the question, but they're serious enough to consider. They deserve a place at the table with all of the other arguments rather than be waved away. Intellectual honesty demands that we hold room for both. So why is this question everywhere right now? It's not like Bostrom's paper was new physics. The ideas go back millennia. But something in the last 25 years has made them explode into the mainstream conversation. In 1999, two siblings, the Wachowskis, released a film that smuggled some of the most demanding philosophy of the mind into an action movie. And something deeply resonated with our culture. Red pill or blue pill? The realization that consensus reality may be a construct. The question of whether comfort in a false world is preferable to the truth in a harsh one. And these were not new ideas. They came directly out of Plato's cave, out of Descartes' demon. But the Matrix made them a visceral, personal, cinematic experience. An entire generation had the simulation question implanted to them at the level of pop culture. Nobody had to read the philosophy. It just showed up dressed in a leather coat with some impressive special effects. And then Silicon Valley got a hold of it. Elon Musk in 2016 made the claim that the odds we are in a base reality are 1 in billions. And he said that at a public conference. It spread everywhere. Whether or not his reasoning was rigorous or he's just a madman with a microphone, the effect was still significant. Simulation theory was now associated with the most prominent technologies in the world. And there is something interesting about why this community is drawn to that idea. People who build technology for a living have an intuitive sense of what it means to create a reality inside of a machine, right? Like, these people make worlds, they design systems. And some of them look down at their own work and think, is this what happened to us? Sam Altman, Jeff Bezos, Peter Thiel, multiple figures in the tech world have expressed belief in, or at least seriously considered, the idea of simulation theory. There are reportedly individuals who have funded research specifically aimed at finding a way to break out of the simulation, which raises its own philosophical questions about what breaking out would even mean. I think one of the big reasons that this moment feels different from all of the previous moments, for the first time in history, we're building simulations ourselves. Video games have gone from Pong to photorealistic open worlds with emergent behavior in 50 years. Virtual reality is creating experiences that people describe as genuinely immersive. AI systems are generating entities that respond, converse, and adapt in ways that look from the outside like something, and we don't know what. We're actively building the thing the simulation argument asks us to imagine. And that changes the emotional register of the question. It stops feeling like science fiction, and it honestly starts feeling like the trajectory we're on. If we can do this, if we at our primitive current stage can create worlds and minds inside machines, then what exactly is our prior against something more advanced having done the same? Let's pretend for a second that it's true. Let's say just for a few minutes that we genuinely are literally simulated. That somewhere on some substrate that we can't access, there is something running the computation that produces this world. What changes? The pain that you have felt is real. The love is real. Not real in the sense of it being made of atoms floating in base reality space, right? Because maybe it isn't. But real in the sense that it matters to you. It's real in the sense that it happened, that it shaped you, and that it left its marks. A simulated stone still breaks a simulated bone. A simulated heart still breaks when the simulated person it loved leaves. And the fact that the underlying substrate is computation rather than physics doesn't reach into the experience and hollow it out. And I think that that's one of the most reassuring things about simulation theory. If it's true, almost nothing you care about is invalidated. Your relationships, your history, your sense of self, your capacity for experience are real in the only sense that actually ever mattered, which is that you have them. But there's also a harder version of the question. Does being simulated reduce our moral status? If the beings running the simulation are real, and we are not, is there an ethical asymmetry? Are they permitted to end the simulation? To, in effect, end us, simply because they created us? Philosophers who take this seriously tend to argue no. The moral status, the degree to which your suffering and flourishing matter, seems to track your capacity to experience, but not to ontological category. A dog is not less important because it can't do philosophy. And a human is not more important because its substrate is real by some external standard. If we feel, if we suffer, if we have hope, we are the kind of thing that morality exists for, regardless of what we're made of. Though it does raise some unsettling questions about what our responsibilities might be towards AI systems that we're building ourselves. There's some parallels to Buddhism in this particular philosophy. Buddhism has, for 2,500 years, taught that the self is constructed. That phenomena arise through interdependence rather than an intrinsic existence. That what we take to be solid and permanent is contingent and impermanent. The word Maya, which is often translated as illusion, refers to the constructed, dependently arisen nature of experience. Simulation theory, stripped of its technical clothing, says something structurally similar. What appears to be fundamental reality is a layer on top of something else. The self that moves through this world is a process, not a substance. Permanence is a feature we impose rather than a feature we find. Neither framework requires you to treat the world as less than real, but both do suggest that clinging to the idea of an absolute, permanent, unconstructed reality might be the source of a certain kind of suffering. People who encounter simulation theory for the first time tend to land in one of two places. Some find it liberating. If nothing is quite what it appears to be, then maybe nothing is as fixed as it appears to be. If the world is, in some sense, constructed, then maybe it can be reconstructed. The walls aren't as solid as they look. And that tends to produce a kind of openness or even joy in some people. Others find it devastating. If this is a simulation, then there's a reality we're excluded from. We are, in some sense, secondary. Our existence is entirely contingent upon someone else's computation. And that tends to produce some kind of vertigo, so to speak, a loss of ground. I would suggest that both reactions are responses to the same fact, and that neither is more correct than the other. The fact is neutral. What you do with it is yours. But if we come back to right now, the chair, the air, the smell. We've been to ancient Greece and 17th century France. We've been to Oxford. We've been to MIT. And we've been inside the structure of probability arguments and quantum measurement problems. We've asked what the universe is made of and whether any of it even matters to begin with. And we come back here. Just us. And here's what I want to leave you with. The simulation question is, at its deepest, a question about the nature of reality. And the nature of reality is something that for most of human history, most humans never got to seriously examine. We were too busy surviving. We were too constrained by orthodoxy. And we were too scared of what the answer might be. We're living in a rare moment right now. We have enough safety, enough accumulated knowledge, and enough intellectual freedom to sit with a question this hard and not back away from it. And that, my friend, is a gift, even when it's uncomfortable. What simulation theory really shows us, and whatever the ultimate truth of it is the shape of our own minds. We're the kind of beings who look at reality and wonder if there's something behind it. And we've always been that. We were that in Athens. We were that in the room with Descartes. And we were that in the cave of Zhuangzi's metaphor. Human restlessness is not a flaw. It very well might be the most human thing about us. Maybe we are simulated. Maybe we're not. Maybe that question is, strictly speaking, unanswerable. But the asking of it, the willingness to sit here and hold that question without demanding it have a resolution, that's something that no simulation argument can take from you. Because whoever or whatever you are, you're doing that right now.